Hello, hello. Sound. Yes, there you go. Here we are. Good afternoon. How's everyone doing? Oi, 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 oi. Oh, what just happened there? Oi. Oh, something went the wrong way. Oh, you like my bottle? It's green. It's actually very green. That's why. This is very cool. Um, I wonder, can you see it? What if I do this? No, I'm not gonna touch anything. It's just, yeah, the bottle is very green, so that's why it's transparent. All right. Good afternoon, Monique, Andres. What's up? Sherman, good to see you again. You must have liked it this morning. And Anguito, I'm not sure if I've seen you before around, but you're more than welcome. How are you doing? Okay. All right, let me organize myself a little bit. I have to, yeah, yes, I need to put this together. So what am I? I have to connect my drawing tablet. There you go. And so I'm going to connect it here, and I'm going to put this in here. And so you should be able to see. There you go. Good. I like this. So, okay, so we're going to start a new one. And then we're going to go back here and here. Wait, what? Oh, because I switched screens. Oh, I see. So then this desktop. Wait. Where's my mouse? Here. So this desktop should be what have I done? This one here. Yeah, exactly. There you go. And this one should be here. And should be here. Alrighty. I think I'm ready. And am I ready? I am. Okay. So where were we? Okay. Hi, welcome everyone. And this is the second live stream of today. This morning, what we did was we completed a section on functions. We are currently recording a course, a class, tutorial, a playlist, a series. I don't even know how to call this, a module. I don't know, but it's on learning C#, okay? And this morning we recorded a bunch of videos about functions and their properties, how to use them in C#. I think what I want to do today is I want to do a longer exercise where I basically just do like a bunch of examples of functions. So like a bunch of different types to illustrate things such as how to use them for different aspects. And I want to use them But I'm going to, yeah. So it's going to be like a longer exercise. I'm just going to be typing like a lot of different functions that do different things. So for example, like add numbers together, combine them, calculate the cross product of a vector, the area of a circle, those kind of things, or like how do you generate numerical series. So that's actually really useful, how to generate like numbers, like a range of numbers, a list of numbers, etc. I actually have some notes about what I may want to do. Yes. And yeah. Oh, and this would be cool. We could actually combine this with Ascii Art. Remember when we did Ascii Art and we printed the stuff to the console? We could generate functions to print Ascii Art to the that would be cool, actually. I think we should do something like that. So I'm just going to make an exercise where I'm going to be creating a lot of functions. Um, and I'm going to be explaining certain things as I go, okay? It's just going to be practice for what we've learned. And then if we have time, which we probably will, I want to do a geometry gem. I have several candidates of things that I want to do, but I guess it depends on what time. How much time do we have? Um, so we'll see about that. And then by the end, I would like to have 5 minutes, 10 minutes of Q&A and questions, etc. So I think I want to do some of that. So shall we just get started? Morning or afternoon, Arastu. It's already for so long for me not to join here, but I haven't been since last year in your personal chat, just the introduction. Thanks for watching that. That course is that playlist is getting pretty popular these days. All right, so how are we going to do this? I'm going to share my screen and I'm going to open a Visual Studio, probably, right? And what is that project going to look like? It's going to be a console application, and I'm going to call it, because it's an exercise, is going to be called functions. Is there a numerical sequences? Functions. Should I call it anything, something sexier? I don't know. Utility. I could call it utility functions. For example, I don't know. It's going to go to my desktop, and yes. I have the light on, yes. And I am going to start with some placeholder console read key. And I have my drawing board here. Let's create some utility functions. I don't know. Not very. I just took a nap, so I'm not very imaginative today, I think. Okay, so I have a list of things that I want to do here. Okay. All right. So let's do that. And what am I going to do? I'm going to start with a bunch of values. A equals. Actually, why don't I start with the function overloads example? I probably want to start here. Oh, okay, Arasto, take a look at this. Yes. So you don't need to, okay, I see what you mean. You're talking about this, no? And you're talking here, you would have like a console write line, right? So you would have this, and it all prints 0, okay? This all prints 0 because you are doing integer division, okay? And remember that in the previous videos we saw how there is a way to there are ways to convert this on the fly to a double. So you can do this, so you can cast this number to a double like that, or you can force, in this particular example, you can force this division to be a normal division if you just force this number to be a double by doing dot 0.0. And if you do that, then the result is going to be exact. It's not going to be an integer. Okay? All right. So where am I? Here. I think I was here, and then I had this, and okay, I had this, and I had some overloads. And let's start with some sample code. Do I want to start with sample code? Yes. Do I want to start with sample code? Do I want to start? I'm a little lost. I'm not sure where do I want to start today. Okay, let's regroup. Yeah, so I'm going to put this somewhere else. I'm going to put this somewhere else as well. Okay, so okay, so I'm going to double sum equal addition 5 7. Okay, and console write line sum. And this is going to start. All right. Okay, let's do this. And the sound is working well. Yes. All right. Oh, I should have drunk more coffee before starting. Okay. This should be A and B. Hello, and welcome to this video where I'm going to be I'm just going to do an exercise where I'm going to build a repository of utility functions, of functions that are going to be useful to manipulate text, to manipulate numbers, to manipulate a lot of things. I don't know. The idea is that this video is going to be the last video of a section on my learning C# playlist tutorial that I've been recording. But I don't know where I'm going with this. Let's start over again. Hi, my name is Jose Luis, and in this video, I'm just going to be doing an exercise where I'm going to be writing a set of utility functions that are going to be useful for doing a lot of things like numerical manipulation, generation of numerical series, some string manipulation, some linear algebra, I don't know, a bunch of things, a collection of things. But the whole purpose of this exercise is to illustrate with examples of everything that we have learned so far about making and creating functions. This video is part of a tutorial series about learning how to code in C#, and it's the last video, is an exercise for the section where we have learned functions. So if you're coming from the playlist, if you think you have everything under control, you're welcome to skip this video. Or if you just want to see me doing like a bunch of examples of like applications of functions, then you're welcome to stick around before moving on to the next section. Okay, so I'm going to start with some placeholder examples from what I did in the previous videos. I'm just going to start with a couple of variables and I'm going to add them together, right? And I'm going to add them with a function that I just created that is called addition, and that it takes two numbers and returns the sum of them both. Okay. Similar to this, I could do another function that would be a multiplication function, where it's just basically going to be a function that returns a number, and it's called multiplication, and it takes two numbers as arguments. All right. I could say multiplication, I could be called multiply, and I was discussing in my previous videos how when I teach, I like breaking things down very clearly in like all the steps, even maybe more than I would when I write real code. So and before when I did sum, I created a variable and I stored the value of the solution, and then I returned that result. For this case, because it's just such a simple operation, maybe I wouldn't even bother to create that intermediate variable. And what I would do is I would return directly the result of multiplying these two numbers, right? And then what I could do here is I could say, let me multiply these two numbers together, okay? And multiplication, okay, my keyboard is a little funky today. Multiplication of these two numbers, all right? And here I'm going to do multiplication. If I run this, I have the sum and I have the multiplication of these two numbers. All right. I also explained in the video how I find it very tedious to write console write line all the time. So I could create like a wrapper function or an alias for console write line, which is just basically a function with a shorter name, but the only thing that function does is calling console write line. So what I can do is I can write a new function, and the return type is going to be void, because this is not going to give anything back to whoever calls it. And I'm going to call it log, or even I could call it print. Print is a pretty common name in other environments. And this is going to take a string, which is going to be str. And the only thing that this function is going to do is going to call console write line with that same message. So therefore, I can now substitute here and say this could be called print, and this could be called print. Interestingly, I get an error here because, as you can see, the print function, it only accepts strings as an input. So something that I can do is I can write overloads. I can write functions with the same name, but that take different types of inputs. So for example, I can just copy paste this whole thing and then just change the type here to be, for example, a double, and this is going to be called value, and then I'm going to print this here. And now I can now print all this stuff here. Okay. All right, cool. What are other things that I probably want to do? Well, I showed in my examples how to calculate the length of a circle. So we're just going to do that real quick for the sake of building up our repository of geometric operations. So this is going to return a double, and this is going to be, for example, circle length, and the input is going to be the radius, right? And the return of this, I'm also going to write it inline, okay? This is going to be 2 times math pi times the radius, all right? And actually, when the function is so simple, it's just one line of code that returns something, we can actually use this shortcut that is called the arrow operator, where basically what we can do is, like, instead of having the block and having the return key, what we can do is we can just use this symbol here. We can use the symbol of the arrow, and then right here directly, what is it that we want to return, okay? This is just a shortcut. You will see this very often for people who are just creating very simple functions. Similarly, we can write a very similar function, which is going to be, for example, circle area, right? And here, what is this going to be? Circle area. And what is the sorry, what is the equation for the area of a circle? There you go. It's pi times the radius square. And we could use math dot power and say, I want to say the square the radius to the power of 2. But for such a simple operation for squaring a number, actually calling a function has like a tiny bit of overhead. It takes like some computational cycles, right? So if you just want to square a value, very often what people do is that they just multiply it by itself. It's easier, it's cheaper from a computational standpoint. So something that we can do here now is I can say, for example, let me define the value of a radius that is going to be 1, and then print to the console circle length is going to be, for example, the value of circle length for the radius, okay? And now circle area is going to be the value of the calculation of circle area. You see, the length is 6.2883185 tau, and then the area of the circle is pi, okay? If I were to do the value of 2, these things would change exactly, and now we have the same value for both things. Alrighty. Now, speaking of power, that is an interesting function that we could implement. So let's say that we want to write more mathematical operations, and we want to say, well, I'm going to write a function that is going to be the power, and then we're going to have the base as an input, and we're going to have the exponent as an input as well. And what I would like to do is I would like to write a function that elevates the base to the exponent. How do we do that? Well, it's going to be very easy. What we need to do is we want to, actually it's not that easy now that I'm thinking about it. So the first thing that we need to do is we need to say, well, I'm going to start with a value that is going to be equal to the base, all right? And actually, I don't think I can use the word base here because it's a reserved word. But what I can do is I can use this. When I want to use a name that is reserved as a variable, so imagine I wanted to call a variable the name double. I cannot use that because that's a special word in C# that I cannot use. But what I can do is I can put an @ symbol in front of it, and then that becomes a variable with that name that I can use. So I can use base here, and I can use the @ sign to make sure that even if it's a reserved word, I can use it as a variable. But that's typically not considered good practice. So I'm just going to call it base value so that it's just not confusing. All right. And then how do I elevate a number to an exponent? Well, basically I take that number and I multiply it several times by itself. Okay. So what I can do is I can say, well, if what I can, because it's a repetitive operation that I want to do, I can just say, well, let me create a for loop that is going to start at 0, whatever. It's going to be less than the exponent, and it's going to be I plus plus. All right. And then what I'm going to do is every time I for each one of these cycles, I'm going to take the current value and I'm going to multiply it by the base value. So I'm going to multiply the result, the accumulated result, over and over again. And then I'm going to return this value. All right. However, I think this is not going to work. Let me try it out. So multiplication, the power is going to be power of a to b, and let's make b 2 to make sure that things are under control. So you can see that 5 squared should be 25, but instead it's 125. That's because since we have this for loop is not correctly designed, because it's going from 0 but it's iterating as many. Hello, sorry, I dropped the microphone. But it's iterating as many times as the exponent. So, but because I already initialized the base value to base value, then actually I have to iterate one time less. So this should be exponent minus 1. And then if I run this code, now I have the correct value here. But this function is also not entirely great because there is a corner case. So if b is equal, whenever I elevate a number to the value of 0, what is the result that I should get? I should not be getting 5. What I should be getting is the value of 1. Any number elevated to 0, the result is 1. So what that means is that first of all here, I should make a check where I say if exponent equals 0, then this should be what I should do is I should return the value of 1, and then otherwise execute this code here. One of the interesting things about, and there you go here, one of the interesting things about the return keyword is that it also, whenever I call it, it also stops executing the function. So after using return, anything that happened afterwards is not going to be executed in that function. So that's why this code here will not be relevant if whenever I return the value of 1. So return is a keyword that is also typically used to exit, to finish a function prematurely and to not keep executing everything that is coming afterwards. Alrighty. What else do we got? What are we doing? Circle length. Okay. All right. Another thing that that I could calculate is, for example, functions not always have to work with numerical values or not always have to return numerical values. They can return other things. And a very common type of returning is whether if something is true or false, right? So Booleans are a very typical return value for functions. So for example, an example of that could be if I take these two numbers, I could create a function that compares them. and it tells me whether if one is greater than the other. So for example, here I could write a function and say this is going to be a function that compares two numbers, tells me if one is greater than the other. So the return value is going to be a Boolean. The function is going to be called is greater than, all right? And then it's going to take A and it's going to take B. And then what I can do is I can either create a variable, I'm going to call greater, and if A is, and I'm going to store the value of A is greater than B, and I can return that. Or I could shorthand that by just not doing the variable, or even by just doing this here. Let me try how that looks like. I'm going to print I'm going to actually write a full message. I'm going to use the $ to do a string interpolation, and I'm going to say, is the value of 10 greater than the value of B? And then here I'm going to print the result of the function is greater than A and B. Okay, so I'm going to print this here, and you can see is 5 greater than 4? True. I'm going to change the values now. Is 5 greater than 6? False. And what if I do both the same number? Is 5 greater than 5? That is also false because it's not greater than, it's equal to. Okay, so so functions that return Boolean values is a very common thing to do. Okay, now let's do like a little bit of functions that are more like geometry style kind of functions. So for example, let's say that I wanted to calculate the distance between 2 points, right? We know that in order to do that, we use the Pythagorean Theorem. Okay, so let's create a function for that. So let's say static, we're going to return a double because it's the distance between points. And let's say that we're going to just do 2D for this one, okay? So what I would want as inputs would be the xy coordinates of the first point and the xy coordinates of the second point. So I'm going to do x0, y0, and then x1 and y1. And then what I need to do here is I just need to calculate the algorithm, so the Pythagorean theorem, and then return the result. So what I'm going to do is I'm going to calculate the horizontal distance between them. So that's going to be dx is going to be x1 minus x0. dy is going to be y1 minus y0. And then the Pythagorean theorem is that the length of the larger side of the triangle is equal to the square root of the sides of the other sides of the triangle squared. All right, so d is going to be equal to math square root. I think I have videos where I've done this before. Dx times dx, so dx squared, plus dy times dy, which is dy squared. And then I can return the result of this. So let's see. So let's, for example, calculate the distance between 2 points. One point is going to be 0, 0, and the other point is going to be 4, 3. And I know that that distance should be 5 because I know that a Pythagorean rectangle of 3, 4, and 5 is a Pythagorean, is a square rectangle. So I'm going to say distance between points 0 and 0 and 4 and 3. And that distance should be print distance between points, and that's going to be dist. So let's see if that's a good result. All right, the distance between points is 5 units. So that's looking good. I'm just going to input 2 other random numbers. I don't even know. And honestly, I don't know if this is true or not, but I think this is going to work. So yes, so that should be 0 and 0. All right. So I do have someone is telling me from the chat that I actually do have a video about that. Maybe it will pop up here on the channel, on the cards, or it will be in the description, or you can just Google in the channel how to calculate the distance between 2 points. All right. Okay, wonderful. Now, going back to the idea that functions can return other things that doesn't have to be numbers. One thing that is interesting is we can calculate, for example, we can calculate if a point is inside of a circle. All right, and the idea is that that's actually quite easy to do. Let me switch to my drawing board. If I have a circle and I know the coordinates of the center and I know the radius, then that circle is perfectly defined, right? And the idea is that I may want to check if a particular point is find itself inside or if it's outside of that circle. The rule is actually quite simple. If I know where is the center of the point of the circle and I know its radius, then it's just as simple as saying, well, let me calculate the distance from the center to that point. And if that distance is less than the radius, then the point will be inside of the circle. If that distance is longer than the radius, then the point will be outside of the circle. Okay, so it will return true or false. So let's see how would we implement that. I'm going to go back here to the circle, and I'm going to create a new function call, which is going to return a Boolean, true or false, and it's going to be is inside circle. Okay, so and then what I'm going to do is I'm going to create a parameter which is going to be cx, the x coordinate of the center of the circle. Another one that is going to be cy, the y coordinate of the center of the circle. Then r, and then the x and the y coordinates of the point that I want to check. All right. So, okay. So then the first thing that I need to do is I need to calculate the distance between the center of this circle and the point that I'm calculating. Now, what's interesting about this, and this is the power of functions, and this is why they're so useful, is that I could write some code very similar to this one here inside of the function and then calculate the distance between the 2 points. But since I already have that function in my scope, I have created it before, then I can actually reuse that function because functions can call other functions. Just like when I was explaining that a console application indeed is a function that the system executes for you with arguments that are coming from the terminal. And then within this function, we are calling all these other functions. Well, from any function, we can always call any other function so long as they're visible in that scope. So here, what we can say is, I'm going to say this is going to be equal to distance between points. All right, and then the parameters that I'm going to pass is the center, the coordinates of the center of the circle, and the values x and y, which have been given to this function as arguments. All right, so basically, whoever calls this function is going to end up also, as a consequence, calling the other function. And again, this is the magic of functions, the modularity, the reusability, and how linked they can be to each other. All right, and then what I can return is inside. I can create a function, a variable called is inside, which basically tells me if distance, if it's smaller than the radius. And then I need to get a new keyboard. Sorry. And then I'm going to return this value here is inside. So let's give it a try. So we have a circle, for example, here, print is inside circle, and then I'm going to calculate the value. I'm going to calculate the value before inside circle, and then here is inside circle, and the circle is going to be, for example, at coordinates 1, 1. All right, the radius is going to be 5, and the point is going to be at coordinates 7, 1. So we can see clearly that because of these coordinates, the point is at 6 units from the center, so this should be false. So let's see if this is false. I'm going to execute this code. Yes, inside of a circle, yes, it's false. And then if I bring it closer, so it's inside of the circle, yes, it's true. Okay, so it looks like our function is working. So we can create geometrical operations also just by taking into account the numerical properties of all these geometrical objects. All right. All right, cool. Shall we do now operations with sequences of numbers? You know, I like those a lot. Let's take a look at those. Archie Coder, what do you got going on there? I don't think that would work because that would actually give it an additional cycle to the iteration as opposed to removing one, which is what we need. Oh, but you start with a value of 1. That's also a good one. Yeah, so that could work. That's a good one. All right. Numerical sequences. Okay. So let's do a bunch of those. And I think with that, we're probably going to call it. All right, so let's first create a bunch of functions that perform operations with arrays. Okay, so let's first create an array, and I'm going to call it. I'm going to just create an array from scratch. So I'm going to create an array of numbers, of doubles, and remember that this is the notation that we can use if we just want to give it like a set of initial values right away, without using a for loop or etc. Something that I find very annoying, for example, is that when we use console writeLine and we want to print all the values of an array, so if I pass an array, instead of printing all the values of that array, what it prints is the signature or the type of that object. It tells me that it's an array of doubles. And I'm actually, just to clean things up, I'm just going to cancel this out, okay? So maybe something that I want to do is I want to create yet another override for my printing, which instead of giving me the type of that object, it just has a for loop and it iterates over all the elements and it prints out them out to the console. So I do this a lot when I do my own coding, for example. I'm going to take an array of doubles. All right, and I'm going to create a print function that just iterates over all of them and it prints them to the console. So very simple. I'm going to set for int equals 0, I is less than values dot, oh my god, I is less than values dot length I plus plus, and then what I'm going to do here is I'm going to console writeLine each one of those values at I. If I now substitute this with print, then I got a printout of all my values. Okay. Now, things that I can do with this. So, for example, in one of the examples in the videos, I showed you how to create a massive addition, how to take an array and add all the values together. So we could create an addition function, which is going to be an overload to the other one that we have, and where we take an array of values, and then we start by starting with a number, which is 0, and then with a for loop, we go over all the values, and we add them incrementally to this variable that we have until we get the result. All right, so for example, mass addition is going to be the result of addition of these numbers. All right. So if I do that, you see that the total addition of these numbers is the value of 30. Okay. All right. Now, things that we may want to do, a very common operation to do is to calculate the average or the mean of a set of numbers. That is like the basic thing if you do any kind of data science or data visualization. So we may want to create a new function here called average or mean, whatever you want to call it. And I'm going to take it as an input, I'm going to take an array of values. All right. So what are the rules for calculating the average of a set of numbers? What we do is we take all the numbers, we add them together, and then we divide that result by the amount of numbers. Okay? So, like I said before, we could copy paste this code to just calculate the massive addition of all these numbers. But since I already have this function, then I can reuse it and then just say double total is going to be equal to the addition of these values that were given to this function. And then now what I'm going to do is I'm going to calculate the average, which is going to be the total divided by how many elements are in this array. And that's going to be values dot length. And I'm going to return the average. So let's see if that works. I'm going to say mass addition, and this is going to be average, and this is going to be average here. Let's see where we're going with that. Okay. All right. So the average is 6, which kind of makes sense. You see how this number is really, really at the center, right? So if this was, for example, blah, 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 then the average will be much, much off. The average is 2004. Okay. All right. Sounds good. Okay. Now, something that is very interesting is we can use functions to generate arrays as well. And something that is very common to do is to generate numerical sequences by using functions. So for example, let's say that I wanted to create a function that is going to give me a list of numbers from starting at the number that I defined, let me do a diagram of that actually. Let's do a diagram of that. So I'm going to, where am I? Okay, here, I'm going to save this, whatever. And then let's say that I'm going to create a function that is going to say, give me a list of 5 values, all right, with starting at 0, for example, or starting at 0, and with the step value being 2 units. If that was the case, then my resulting list, and this is typically referred to as a series, is going to be 0, 2, 4, 6, and 8. Correct? Because the values between them are, the gap between them is the value of 2. So let's take a look at how to implement this here. So what I'm going to do is I'm going to call this function Numerical Series, and then what I'm going to do is that the first value is going to be the start, and then how many elements is going to be an integer in this case, because I don't want to have like 0.5 elements. And then I'm going, and actually I may want to do the step value here as a double, and then the last one is going to be count. So how many elements do I have? Now, interestingly, what is the return type of this function going to be? The return type is going to be double, but it's not going to be one single double. It's probably going to be an array of doubles. So in this case, the type is going to be an array of doubles. Because it's C#, I could also choose to return a list of doubles, but it turns out that because I already know from the definition of this function how many elements my array is going to have, I can calculate that very easily here with this value. So arrays are a bit more performative if we know always what we're going to have. So in this case, I'm just going to choose an array. And then what I'm going to do is here, inside of the function, I'm going to define an empty array. I'm going to call it, for example, list. And then it's going to be a new array of doubles with a capacity of count elements. So how many numbers I want to generate. And then I'm going to iterate with a for loop. I'm going to say this is going to be equal to count elements and I++. And then what I'm going to do is I'm going to say for each one of these elements, so for list I, the value of this element needs to be something that relates to this equation, this list that I just expressed here. Oh, I'm a little fussy right now. And the rule is going to be very simple. If this is element in position 0, 1, 2, 3, and 4, the rule is that the value in each one of these positions is where they are, so the index number, plus, so the start number. Oh, I'm going to mess this up, sorry. The starting value, so whether if we start at 0, 10, whatever, plus where they are in the position times the step size. So that looked terrible. I need to adjust this a little better. But I think this is actually much better just seeing here. So this is going to be the start value times where they are in the list, in the first element, second element, third element, times the step size. So if the gap is 2 units, 3 units, 2.5 units, etc. And then we're going to return this list. Let's see if that works. So I'm going to replace here these hard-coded numbers. And what I'm going to do is I'm going to say, I want to create a numerical series which is going to start at 0. I'm going to do the exact same example of the diagram. The step size is going to be 2, and I want to have 5 elements in this list. And let me print that to the console. So I'm getting 0, 2, 4, 6, and 8. That's pretty neat. What if I wanted to start at 10? Then I would get 10, 12, 14, 16, 18. What if I wanted the gap to be 2.5? Then I would get 10, all the way up to 20. All right. Okay. So how is that sounding? How is that looking? All right. How's that going? What else am I going to do after this? I think that's going to be about it. Yeah, I think that's going to be about it. I'm getting a headache. I don't know why. Oh, Monique. It's easy, huh? All right. Oh, we need to do the Ascii art, the function that does Ascii art, right? Okay. So now we're going to do a numerical range, and then we're just going to do Ascii art, which is more fun. And we're going to stop it there because otherwise this video is going to get quite long. And for this series, I don't want videos longer than 45 minutes, an hour, maybe too much. That's just too much. Oh, I haven't done anything like the cross product or something like that. Do I want to do cross product? Or do we want to do dot product? Well, I think we're probably not. We're probably not there yet. Or it's probably not. Or we're probably past that point. Okay. Yeah, what am I doing wrong? Why is this not working today? I don't know. I have to move the speakers. The speakers are on the way. Um. What else are we doing? Also, why is this? Why is this thin? No, this is too much. And this is too thin, right? This is a little too thin. Can I get brush properties? Where do I find those properties? Brush library, ballpoint. Hmm? Oh, I like this. Felt pen. Oh, I like this better. And how can I add this to the library? Felt pen, brush properties, brush library. Okay. Can I do two? All right. So what if I? Yeah. Okay. This is a little better. Yes. Okay. All right. All right. Let's try another way of creating numerical series or series of numbers. It's very common to do it the way we've done it, with a start value, the gap size between numbers, and how many values do we want. But a very common way of doing this is also by defining where do I want to start, where do I want to end, and how many steps do I want to have in between. All right, so let's take a look at how that looks. So let me say I wanted to create a range which is going to start with the value of 2, for example, is going to end with the value of 8, and we're going to divide this range in, for example, in how many steps. So steps is going to be 3 steps in between them. The range for this one will probably look something like 2, 4, 6, and 8. And keep in mind that in this case, we said that we had 3 steps, but we end up with 4 values because we have 1 step, 2 step, and 3 steps. Sorry, that last one shouldn't be there. So it's like, the idea is that if we start with the value of 2 here and the value of 3 here, if we divide this range into 3 steps, so what are the values at equal intervals that are in between those numbers? And that's why we have the value of 6 and the value of 4. If we were to say, for example, I want to divide this in 3 steps, I want to divide this in, I don't know, 6 steps, for example. So that would be this one and this one. Then what we would get is, we would get something, for example, we would get, well, actually here, that was a terrible example. You see where I'm going with this. So actually, you know what? Let's start over. Let's not do, okay, we're not doing this one. We're not doing this one. Let's start from scratch. I'm going to start over. I'm going to start over again. Nah, let's start over again. Okay? And let's start over again because, what do I want to change about what I did? I want to design more graphically. Yeah, I want to discuss this example graphically. So let's start over again. Okay, so another way of creating lists of numbers, as opposed to what we've done before, which is we chose the starting value, we chose the gap, the step between numbers and how many numbers we wanted. Very often, a very common thing that we want to do is generate lists of numbers where we know where we want to start, where we want to end, and how many intervals do we want between those numbers. This is typically referred to as a range, and the idea is quite simple. Let's imagine the number line, right? And let's imagine that we start, for example, at the value of, I don't know, let's say that we start at the value of 4 and that we want to end at the value of 10. These are the numbers that we want. And we know that we want to divide this interval in 3 steps. So I want a number here and I want a number here at equal intervals. We know that this is going to give us the number 6 and the number 7 here at the center, right? We also know that if we instead we want, for example, 4 intervals, right? So we would probably end up with something like 5.5, 7, 8.5, and 10, all right? And what's interesting is that we need to keep in mind that what we are defining is how many intervals are between, how many steps are between the numbers, then it turns out that the actual number of numbers, the total of those numbers, is 1 unit greater than the number of steps. So if I have 4 steps, I end up with 5 numbers. And if I have 5 numbers, I end up with 6. You know, I'm messing this up too much. Okay, so so the rule is going to be very simple. For each one of these numbers, the rule that we're going to do is that the number is going to be equal to, the number that we're generating is going to be equal to the start number, so that's going to be this one here, plus where this number is sitting on the list, so this would be 0, 1, 2, 3, and 4, times the gap between them, all right, or the step size. However, we don't really know the step size because the only thing that we know is the number of intervals. But the step is going to be very easy to calculate because the only thing that we need to do is we need to calculate the length of the interval. So that's going to be the end value minus the start value, and divide that by how many steps are in our range. Oops, I'm right there. Okay, so then let's do that with code. So what I'm going to do now is I'm going to say static double new numerical range, and let's say I'm going to define the start of this range, I'm going to define the end of this range, and I'm going to define how many steps I'm going to divide this range in. So now what I would need to do is I would need to calculate the step. So that's going to be the end value minus the start value, and all of that divided by how many steps are on the range. And then it's going to be very easy. I'm just going to create a list of numbers. Is going to be the number of elements for this list is going to be the number of steps that we have plus 1 unit, as we just described in the diagram. And then for int I equals 0, I is less or equal to the number of steps, all right? Or is less than the number of steps plus 1, however you want to see this, it doesn't really matter, right? Or an I++, and, oh, I'm messing this up again. What's going on here? Okay, there you go. And then, so what I'm going to do is for each element of the list, what I want is, I want that value to be equal to the value of the starting point of the range plus I times the step size of this, and then I could just say return the value of of the list. And actually, you can see that this list here, this code here is super similar to this one. If you wanted, something that we could do is we could just say, because I have the step size now, what I could say is, why don't you just return a numerical series where we also start with the value of start. The step size is that value that we have calculated, and the number of elements is going to be the number of steps plus 1. Okay? Both work exactly the same. So let's try this one, for example, numerical range, and that's going to be from the value of 4 to the value of 10, and we're going to divide this in 4 intervals. Okay, so if I run that, 4, 5.5, 7, 8.5, and 10, just like we had in the example here. And let me show you how this works exactly the same as just calculating the step size and calculating the numerical series using the other function that we already created. So if I run this code, now it should work exactly the same. All right. What's interesting is that we can flip the direction of both by just saying that one has to be a negative number, or even not, maybe not even a negative number. It can just be like a number that is lower than the previous one. So if I do that, you can see that we now have a decreasing range because the end value is smaller than the larger value, than the start value. Okay, so whichever code you feel more, they're both ways work pretty well. Okay. Alrighty, Andres. Yes, I have not explained the difference between static and non-static, and I will not do that yet. I will do that when we talk about classes and object-oriented programming. We're just not there yet. It will make sense once we discuss that topic. Okay, and I think the last thing I want to do is I want to do some Ascii art, right? Who wants to do Ascii art? Woohoo! So let's take one of the examples of the Ascii art exercise. And for example, I don't know which one of them. Rectangle width. Oh, I forgot we did this. So 50 rectangle height. And that's going to be 10. Oops. Okay, border rectangle. Solid rectangle checker pattern. Oh, this is cool. Well, I forgot we were so neat when doing these things. Okay. So maybe I can talk about that. Oh, that would have been cool for the console app. Whoa, that would have been cool. That would be like a super cool app to write a console app that you type in some number and then boom, it generates the rectangle. Whoa, that would be cool. How can we do that? Where would that fit into what we've done so far? Maybe it's an additional exercise. So it's exercise 6. Hmm. How can we do that so that it's... Yeah, that's a pretty cool exercise. Hmm. Mm. Where can we do that? Try my console app, Ascii Art. I know. Um, we could just create that function, show it here in this exercise, and then do another exercise where we just create a console app that does it. Well, let's just do it here, and then we'll take care about that later. Okay. All right. The last example that I would like to do today for this exercise is to create a cool function that you can call, and then that creates like some very nice ASCII art on the screen based on whatever parameters you give it to the function. And if you remember from a previous exercise video on this series, we spent a full like exercise just doing ASCII art and writing functions and for loops that created ASCII art. And we even excuse me, and we even write something that would take input from the user. So for example, I could type in here like 50 characters wide rectangle, and the height of the rectangle is going to be 30 characters, and then each rectangle would have that size. This looks square because like the form factor of characters is not square. So let me do it again. Let me say 50 and 20, for example, and then you see that now it looks more like a rectangle. But it would be really cool if we were able to create a function that would take two numbers. So for example, the width and the height, and maybe the border radius and the border of this, and create a rectangle with those parameters. So what I'm going to do is I'm basically going to go here, what it says border rectangle. This is the code that we wrote for this is the code that we wrote for creating this second rectangle, the one that is hollow inside that has a border. Okay, and then what we can do is we can just copy this. This comes from the previous video, and then just wrap it inside of a function. This function is going to be a function that is going to draw an empty rectangle. Because what this function is going to do is just going to draw things on the screen. It's not going to compute any numbers or anything. The return value of this function is going to be void. So we don't want to give anything back to the user. All right. And then well, I'm going to call this function something like draw empty rectangle, and it's going to take some parameters. So for example, it's going to take oh god sorry. Sorry about that. It's going to take the width of the rectangle, it's going to take the height of the rectangle, and it's going to take the border width, for example. And my keyboard is doing my keyboard has its own life somehow. And then what I'm going to do here is I'm going to copy paste this, and I'm going to replace a few things. So I'm not going to print this anymore. Now border W is going to, I'm just going to replace all instances of border W with the actual value of that we're using, the name that we're using for the function. So that's going to be here, 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 and here. But everything else is going to be the same. Maybe even I'm just going to use a dot here to draw out the emptiness. All right. And then you can see that now it's just going to be super simple. The only thing that I need to do is in the main code, I just say draw empty rectangle, and can you draw 50 units wide, 20 units height, and for example 4 pixels, 4 characters for the width of the rectangle. And if I run this code, I get my Ascii art, I get my big rectangle, 4 units in the border, and then these dots in the center. Yoo-hoo, right? And yeah, and this is actually, yeah, this is quite cool actually. And you know what? Why don't we actually create a console application that we can call from the console? Um, why don't we create a console application that we can call from the terminal, and we give it the parameters, and then it just prints it to the console? Actually, I think that's a good idea. So I think I'm just going to record another video, and we're going to do that in the next video. So thank you very much. I hope this video was helpful to wrap up and to solidify all the ideas around how to create functions and everything that we have learned in this section. If you like this video, if you like this series, if you want to support the channel, please go ahead and like this video, subscribe to the channel, turn on notifications and all those things. And I guess I'll see you in the next section of this playlist. Thanks a lot. All right, I think I'm going to do that. I'm going to create a video where I'm just going to combine the two projects. I'm going to combine the idea of creating a console application that we can run from the terminal, and taking some input, parsing that input, and then drawing that on the drawing that. Actually, this should be integers, right? Yes, this should probably be integers, and this should also be integers. Because we have finite characters. Yeah, that was not great. All right. So let's do that. And how are we going to do that? We're going to do that. How are we going to do that? I'm going to start. Should I? I probably, for this video, I probably want to do the thing where I implement it first, but then I record the intro at the end, and then I show this thing working at the end, right? Yes, so I probably want to do that. Okay. All right, so I'm going to move this all the way here. Okay, I'm going to move this also here. Okay, and then so Visual Studio. Okay, and so I'm going to start doing the thing, and okay. All right, so super simple. This is actually going to be a very short video because we've written all the code that we need in previous examples. So I'm going to be doing a lot of copy pasting and referencing which videos this code is coming from. So the first thing we're going to do is we're going to create a new project. It's going to be a console application in the .NET framework. And I'm going to call this project with the same name of the command, the console app or command that I'm going to be creating. So I'm going to call this draw empty rectangle, for example. I'm going to drop this in my desktop so that I have easy access to that. I'm going to choose a lower framework, .NET framework level, so that it's as compatible as possible with other applications. And I'm going to start this empty program. Okay. Now, what I'm going to do is I'm going to bring in the function that I created in my previous video, where I was doing a full set of utility functions. I created a function that given any, and I'm going to copy paste it here. I created a function that given a, that was called draw empty rectangle, and the fact that these two things have the same name is just coincidental. They don't have to. But this function was just a function that took the width and the height of the rectangle in integers, because it's characters, is finite quantities. We can't have 2.5 pixels or 2.5 characters of a rectangle, and also the width of that rectangle. And this code here was the one that generated with Ascii Art on the console. It printed out this control rectangle. If you want to learn about how this was done, you can go back to episode or exercise 4 on this playlist where we were doing Ascii Art, and I was explaining how to do this, right? The only thing we have done here is we have wrapped it in a function so that we can copy paste this between programs and access this functionality, right? And then if you remember from the Ascii Art video, the same one, we also had in that video a few lines of code that gave me access to, here in the main program, that gave me access to taking as inputs, taking the width and the height of a rectangle. Okay, so this would stop in the console and would let the user type their input, and then we would generate the rectangle on the video. I'm a little fussy for this video as well. We would generate the rectangle in line with code in the program. So now that we have a function, it's just as easy as saying, can you say draw empty rectangle, and can you use the oops, so actually yes. So something that I forgot to do is I need to bring in first, I need to copy, and I need to make sure that I convert the values that I'm reading from the console, which are coming as strings, and I need to convert them to integers. And also I probably want to add something more. Type the width of the border, and that's going to be, here I'm going to call this border string. And now I'm going to add another line where I'm going to say border width is going to be equal to the conversion from border string to an integer. And now that I have this, what I can do is I can here now call the draw empty rectangle and pass in those parameters that I just passed. So that's going to be width, height, and the width of the border. And for this console, I really don't need to add this like read key thing that we've been doing to stop the console from shutting down, because this project is intended to be run from an actual console. So I will go back to the console, to the terminal, to the bash, which is kind of what I want to do. So I'm going to save this. I'm going to build this solution, and I have just generated an executable file that is this program and that I can run from a terminal. And if I open where in my system that is, you can see that I have a folder called draw empty rectangle. And if I go all the way in there and into binary and debug, you can see that I have this file, draw empty rectangle.x, which is an executable file that I can run on Windows, and that will execute this console application. So what I'm going to do is I'm going to open a terminal by searching in my Windows system for a command prompt. So I just type command or command prompt. You can't, it's on my other screen, you can't see it. But I just open this here, okay? And this, so what I can do is I can copy this whole route and type here cd and paste that route so that I land on where this program is. So I can now type there, and you can see that I have all this stuff here. And actually these two files, they're not really necessary, so you can delete them. And I just have now my draw empty rectangle. So I can now start typing draw, and if I'm a little lazy and I don't want to type the whole thing, I can just type the first few letters and press tab, and then the whole thing will show up. Let me clear the screen before. I'm just going to type draw and the tab, and you can see that the first thing that it adds, can you tell me the width? Okay, 50. Can you tell me the height? All right, 25. And can you tell me the width of the border? That's going to be 3 characters. And then as I do that, boom, it just draws that rectangle, and I just got it. I just executed this from the console. I'm going to do the same, draw empty rectangle with more values, for example, like 120 and 15 and just 1 unit. Oh, and because this is much larger than the console, okay, so let's just only do 100, 15 and 1 unit. And you can see that now the rectangle adapts to that, okay? So that was very easy, actually. This is a continuation. This example is a continuation of the video that I did before, where I explained how we can create console applications that can take input. So we can create console applications that we can run directly from the terminal. Okay, it's just that I have brought in now this function that we used to create Ascii Art, and I have wrapped it inside the console application. We can choose to have applications that take input from the user like this. But remember that in my previous video, I also explained how we can choose to have console applications that have the arguments right after one after the other. So I could choose to do something where I may want to say, draw empty rectangle, 80, 30, and 3. These values corresponding to the width, the height, and the border. If I do that now, this is not going to do anything, so it's still going to ask me for the values. So I can press Ctrl+C to stop the program, and I can change my program to, instead of taking input from the user, what I can do is I can try to get that input directly from the arguments that are typed in on the terminal. So something that I can do is I'm going to copy and paste this. I'm going to remove this, and then I'm going to say the width is going to be the first argument that is passed in the argument. So that's going to be arg0. So what I'm going to do is I'm going to try to convert to an integer the first value that is given as an argument. Here, I'm going to try to convert to the height the second value that is given as an argument. And here, the third value. All right? And then if I save this and if I build this, my draw empty rectangle has updated and now behaves differently. So now if I do draw empty rectangle, oops, what have I done? Oops, okay. So I'm going to say draw empty rectangle with a value of 80 and now the height of 30 and the border of 2. Now you can see that the rectangle shows right away without having to take input from the user. The input has been passed as arguments. The input has been passed as arguments in the same call. All right. Well, I hope this was not confusing enough, but now that we're here, I might just want to play a little bit with this. Can we create like a really tall one, like a 20 and like 200? Oh, what have I done here? Okay, so 20 and 201 pixel. Whoop! So like a really tall rectangle here. Yep. All right. So I think with this, we're going to finish the video here. You are ready now to create your own commands that you could run from your system and to do fancy things, fancy calculations, or to draw cool stuff on your console, on your terminal. Okay. Thank you very much. Let's move on to the next section on this series of learning C# for computational designers. And I'll see you in the next video. If you like this stuff, just feel free to like, subscribe, etc., and check out everything else that we have in the channel. Thanks a lot. All right. Okay. Oh, I am a little tired right now. How's everyone holding on? Okay. All right. Am I recording? I am recording. All right. How am I feeling? So we're good here. Okay. I think we're going to call it a day today. I don't think I have the mental bandwidth to do more, to do anything, to do a geometry jam from scratch right now. I'm always super optimistic about time, clearly, and I never fulfill. I think I may just want to open it up to Q&A and social and questions or anything. And I think what I will do is to just probably next stream is going to be just it's going to be the geometry gems. It's going to be grids of points. I want to do point grids, so I would like planar point grids. I want to do cylindrical point grids. I want to do spherical point grids. I want to do maybe volumetric point grids. I don't know. And I also want to do meshes with those grids. And I want to do also change of basis. So I want to have things like go from one plane coordinate system to another coordinate system. And I want to explain how to do that with vector algebra. So that should be cool, actually. So maybe we can do that next time we see each other. In the meantime, we will be processing these videos and posting them to the playlist. And the next thing probably that we want to do for the playlist, I think we're ready to now talk object-oriented programming. I think we're ready to talk sines and cosines could be good for the grids, that's true. I think we're ready to talk classes and objects, and maybe we can write like a small geometry kernel, and we can do vector algebra like sines and like dot products and cross products and that kind of stuff. That would be really cool. All right. Any questions, comments, concerns? How are we doing? I'm ready to start the weekend, I think. All right. Well, I'm going to start wrapping up. I'm going to still be around for a couple minutes in case anyone has questions or wants to chat. Okay. This would be good. This is going to be good. All right. Well, everyone have a great weekend too. And I'll see you. Maybe I'm kind of thinking of doing something midweek. How is my week looking? My next week? Oh, it's I have a lot of stuff, actually. But maybe I could do Wednesday morning. How would Wednesday morning work for folks here in the call? How does a midweek Wednesday morning geometry jam? How does that feel? How does that look like? You probably have jobs and things to do, right? I do too, but this is actually a lot of fun. An open house. Yeah, I don't have anything going on next weekend. All right. Okay, so I think I may do something midweek, and just stay tuned for what it's going to look like, and then otherwise I'll see you next weekend probably, or whenever. Just stay tuned and see when. Oh my god! Okay, this is getting bad now. All right, I'm gonna stop talking. Cool. See you. Have a good one, everyone. Stay safe. Stay healthy. Go outside if you can, but wear a mask, okay? And I'll see you next time. Bye.